All right. Can everyone see? Can everyone see my screen right now?
Yes, I can see.
All right. So I'm going to be explaining assignment 6 in depth, uh, specifically the different functions needed, and I'm going to give an explanation on a few different matrix, um, few different pieces of matrix math. So starting with the non-member functions, the functions that are not a member of the matrix class, we have int file open. And all this does is it opens the file using the file name. It returns -1 if the file is not open, else it returns 0. In read file reads from a file into this array. Uh, the array 2D is always a 10 by 10 array, and you can always assume that the file will have the correct amount of numbers needed. You can assume that for this 10 by 10 array, there will be 100 entries in the file. And for void print matrix, you need to print the int matrix in a formatted manner. You've already done this before on 2 different assignments. I'm not going to go over the specific formatting details. Just know that for print matrix, the current row and column must be printed in red in the upper left corner of the cell, with the value placed inside with the value inside the matrix at that row and column placed in the middle of that cell. The 2 variables n and m, those are the number of rows and the number of columns. So these 2 functions are their friend functions, and a friend function is not a member of a class, but because it is a friend, it can use private class variables. So because we are declaring this as a friend inside the .h file, that means that even though matrix is a private member of C, the matrix is a private member of the matrix class, this is a friend, and this can access that private variable. So for this operator overload, you want to print C matrix with cells. Same thing as with the print matrix function. Only difference is you don't print the row and column in the corner of the cell, and you print the value in green. And what makes this operator overload special than just a normal print function is uh, really taking advantage of the operator overload advantages. So in this function, you won't use cout to print because we're overloading the operator. You're going to use s to print. You're going to do like cs print, and then some stuff. And then at the end of the function, you return s. Returning s would allow you to like string these together, like print something matrix. Just know that you have to return s. Now the operator overload for the input arrows, the stream in, is a little bit more complicated. So for this function, this operator overload, the first thing you want to do is you want to print enter matrix element and then the size of the matrix times size of the matrix. So it might be like enter matrix element ... 5 by 5 or 2 by 2, etc. And then for each row and column, you want to print the row and the column, and then you want to read in from S into the matrix at current row and column. And just like the previous operator overload, you want to use S, our overloaded argument, as though it were C in. So in this instance, for these print functions, you'll use C out like normal. But instead of C in, you'll use S. And then at the end, you will return S. All right. So now we're going to start with the actual member functions of the matrix class. So matrix display, same thing as the previous display functions. Print the matrix formatted in cells. Print the current row and column in red at upper left corner of the cell. And print the value inside, not in any special color, just plain text. Now for void deallocate matrix, first check if matrix is not null. And if it's not null, then deallocate each row and then deallocate each matrix. And we're creating a special function for this so that anytime we need to deallocate the matrix, if there is one, we can just call this function. Now for the constructor, once again, you've seen this before. I'm going to go over it again. Check if the size is less than the matrix minimum size or larger than the matrix maximum size. If it is, set the size of the matrix, this.size, to 0, and then set matrix to null, and print an error message. Else, set this size to the past size, allocate the matrix to a 2D array, and then set each index to 0. For the destructor, all you do is call deallocate matrix. That's all you do. Now for create matrix, this is a little bit complicated. So create matrix gets past a 2-dimensional integer array. This is not of dynamic size. This is always going to be a 10 by 10 array. And so for each row in matrix, you want the row and column of the matrix, because you're going to set, in this function, you set each value inside the class matrix. And you use this past matrix as a reference. So what you do is you read a single index from the user. One value. It can be like 0, it can be 7, it can be 24, it can be 99, it can be anything in between, like here. And the reason why is because you're going to use this one value and get the row and column from the one index that you get. Because you're going to use this row and this column to get a value from this matrix and move that value into this matrix. So while you're doing this, you need to keep reading in a single index from the user while it's out of bounds. If it's less than 0, it's too low. We can't have a negative number in the matrix. If it's greater than 99, that's too big. There is no index higher than row 9 and column 9. When you have a valid index, you can get the row into this matrix by dividing index by 10, and you can get the column into this matrix by doing index modulus 10. And you can just use the row and column from this matrix to set the value in a different row and column in this matrix. So just understand, this row and this column are not going to be the same thing. This is going to loop through every value in this matrix, and then the user will pick a row and column from this matrix. Now for the copy constructor just lets us pass a matrix. If we're creating a matrix, we can pass a matrix to this matrix that we are making and just say, have this matrix objects that we create just be a complete copy of this matrix. So you want to set, and for this, just assume that the size, assume that there are no problems with size or matrix. So set the size of this matrix to the size of the pass matrix. Allocate a 2D array for matrix, and then completely copy over the matrix from this into the matrix for the class. All right, now we're going to do some operator overloading. The first operator we overload is the plus sign. So using this in with two matrix objects would look like this. Now you want to create a temp matrix, because we don't want to actually change the value of either of these matrices. We just want to display to the user what that addition would look like. So you create a temp matrix that only exists inside the function. And then for each row and column in the temp matrix, that row and column equals the addition of the corresponding row and column in the matrix, in this matrix, and this matrix. And once you've added each column from this matrix, each row and column from both these matrices, and you've placed the values in the temp matrix, print the temp specifically using cout temp. Literally type cout whatever the name of this matrix is. If you want to call it M, if you want to call it X, if you want to call it temporary, whatever, you specifically have to use this line of code, because remember, we overloaded this operator so that we can just cout a whole matrix. Matrix operator minus is very similar. It is the exact same, only difference is it's minus. It's everything in this array or this matrix minus everything in this matrix. So you would just change a couple of things to say the result of matrix 1 minus matrix 2, and then just do subtraction instead of addition, and then print the matrix. All right, so for the operator overloads for plus, plus, and minus, minus, they're all very, very simple. You just, for each entry in the matrix, you just increment it by 1. These overloads are just to say, so we can have like matrix 1 plus plus. In the same way you can say like some integer variable plus plus. So we overload these functions so that way we can have a function. We can have our function. Sorry, we can have our object of matrix basically use it with regular math. Now let me get rid of this because I need to start showing some matrix math. The negative operator, or not the exclamation point operator, is the All right, so for this operator, you want the transpose of a matrix. Now, once again, you want to create a temp matrix because we don't want to transpose the actual matrix. We just want to create. Let me do this. All right. Uh, so here we have our matrix. So we want to copy this matrix into this matrix, but we want the transpose. So to transpose a matrix, you take the rows and the columns and you flip them. So we want to move this matrix into this matrix. But to get the transpose of this matrix, we would say, all right, for each entry, move it to this matrix, but flip the row and flip the row and column. So to move here, all right. So to move this, the row and column are 0 and 0, so nothing would happen. But for this one, the row and column, row is 0, column is 1. So to transpose the matrix over to here, the row would be 1 and the column would be 0. So this is where its entry would be. For this one, the row would be 0, the column would be 2. So when we transpose it to this matrix, the row becomes 2 and the column becomes 0. Once again, for everything, row 1, 0 becomes 0, 1. 1, 1 becomes 1, 1. 2, 1 becomes 1, 2 becomes 2, 1. 2, 0 becomes 0, 2. 2, 1 becomes 1, 2. And 2, 2 becomes 2, 2. Is everyone following along so far, or does anyone have any questions? All right, let me go on to the final set of operator overloads. So for our final set of operator overloads, we have multiplication and the quality, the equal sign operator. I'm going to explain this first because it's a lot more simple. So this would look like We want to say make this matrix equal to this matrix, but we want to create our own special function for it. We want this operator to work in a very specific way, so we overload it. And in our overloaded function, we first call deallocate matrix just to make sure that this matrix is empty before we start allocating any data and setting anything. So we set the size of this matrix to the size of the past matrix, size of this matrix. And we allocate a 2D array for matrix, and then for each row and column in this matrix, we copy the value from this matrix. Now for the multiplication operator, matrix multiplication is a lot more complicated. Okay, it's not a lot more complicated, but it's a little bit more in depth than matrix addition. So for matrix addition, it was very straightforward. And I'll show you addition and subtraction and multiplication. But first, I'm going to go over the algorithm. So we want to create another temp matrix because we don't want to overwrite any of the matrices. So we first want to print result of matrix 1 times matrix 2. And then for each row and column in temp matrix, that row and column temp matrix equals the dot product of the corresponding row in this matrix and the corresponding column in X dot matrix. Once this loop is over, you print temp using cout, using the temp, the matrix overloaded cout function. All right. So now I'm going to show matrix math, and this is where things can get kind of complicated. So matrix addition is very simple. It's just for each row, for each index, add the number together and put it over here. So for this matrix, 1 plus 10 is 11. 3 plus 22 is 25. 72 plus 3, 75. 21 plus 8 is 29. 8 plus 4 is 12. 4 plus 21 is 25. 12 plus 12 is 24. 4 plus 16 is 20. 81 plus 9 is 90. All right. Now for matrix subtraction, it's pretty much the same thing. We just do minus instead of subtraction. So 1 minus 10 is negative 9. 3 minus 22 is negative 19. 72 minus 3 is 69. 21 minus 8 is 13. 8 minus 4 is 4. 4 minus 21 is negative 17. 12 minus 12 is 0. 4 minus 16 is negative 12. A1 minus 9 is 72. All right, very straightforward. Now for matrix multiplication, it's not that simple. It's not quite that simple. This is where things get complicated. So, all right. So we want to get the value for this row in the matrix. Well, how do we get that value? Specifically for this square at this row and this index. Well, to get that value, we need to take this this whole row here and this whole column here, and we need to get their dot product. Well, what's their dot product? Okay, the dot product is the sum of the multiplication of each of these numbers. Well, what does that look like? Well, I'll show you. So it's 1 times 10 plus 3 times 8 plus 72 times 12. What does that equal? Well, that equals 898. So that would be the value for just this one square. So we did this just to get the value for this one square. And I'm going to walk through an entire matrix multiplication, because this is something that you're going to have to do for later classes, just like math classes and other computer science classes. All right, so now I want the value for this square. Well, we go over to here to this same row and this column, and we get the dot product again. So that's 1 times 22 plus 3 times 4 plus 72 times 16. And that equals 1,186. All right, so now we want to get the final square on this row. So we take this row and this column, and we get the dot product again. So 3 plus 63 plus 648 equals 714. All right. Well, now we want the value of this square. All right, so now we want this row from this matrix and this column from this matrix. So we do 210 plus, actually let me write it like this. We want 21 times 10, these two values, plus 8 times 8, the multiplication of these two values, plus 4 times 12, the multiplication of these two values. That equals 322. So everyone following along so far, does anyone not quite understand exactly what it is we're doing? Once again, if you do have a question, it's better for you to ask it here while we're on video, just in case a student watching this video later on has the same question.
So just to make sure, so the first matrix would be like the row, and then you multiply it by like the column of the second matrix.
Yes. In specific mathematical terms, you're getting what's called a dot product, which is when you have two lists like this, just two lists like this, and the dot product is one value. It's just a single number you get from saying multiply this, and multiply this, and then add all of those numbers together to get one number. So you're saying for each box in this, take this row from here, and then take this column and go here, and then use these as the lists to get a dot product from. And that one dot product is the value that goes in here.
Thank you.
All right. I'm just going to finish up this last these two squares on this column, because I think at this point it's kind of, you can kind of see what exactly it is we're doing. So I'm going to get this row. Then I'm going to get the column this box is in, go here. And then say, all right, 21 times 22 plus 8 times 4 plus 4 times 16. And that equals 558. And I put 558 there. For the final box that I'm going to do for this matrix, we take this row, get that row in the first matrix, then take this column, get this column in the second matrix, and then get the dot product again. It's 21 times 3 plus 8 times 21 plus 4 times 9. And that equals 267. All right. I'm not going to do the last row of this matrix. I think I think we've already kind of done enough. So this might seem really, really complicated to do in code. I'm not going to tell you exactly how it's done, but I'll give you a hint. You aren't going to need more than a double nested loop. So you would have so having to get the combined dot product for any one random row. Like getting the dot product for this one row might seem extra complicated because you need this row for that one square and this row, and then you need to multiply and add everything together. But you aren't going to need more than one extra loop. Because you'd loop through. So for these outer loops, think of them as looping through this matrix. So for every row in this matrix, and then for every column in this matrix, then for think of K as being both the rows and columns of this matrix, of these two matrices. You'd want to get the multiplication of this box and this box, and then add it to some kind of sum, then get the multiplication of this box and this box, add it to some kind of sum, get the multiplication of this box and add it to the running sum. And then when it's over, that running sum is the value that goes inside here. Does everyone kind of understand what I mean. Once again, we still have 2 hours and 17 minutes left. So this lesson can still go on for quite a while. So if there's any questions you have, if I didn't explain this very well, feel free to tell me. All right. Oh,
I have a question, but it's about the increment and decrement. So I noticed there's like a post and a pre-decrement. Like, what's the difference between those two?
there's really no difference between the two. For post decrement and pre decrement, it's essentially the same thing.
Okay. So like, it'd be the same thing inside each function.
Pretty much. Yes, it would.
Okay. All right. Thank you.
All right. All right. Well, if no one has any more questions, I'm going to stop the recording. I'm going to resume normal office hours. Thank you all for coming. I hope that this helps you guys out. Have a nice day.